Hi everyone, Titus here for another Unreal Engine tutorial, and in this video I'll show you how to create a mini-map with an offset. This will be helpful for those who have created levels that are not centered at world origin. Let's go ahead and just jump right into it. Alright, so starting off, I can play this simple little prototype I have set up. You can see I even have the mini-map staged. It's currently not moving around, so we're basically going to kind of set that up. But what makes this one different and unique to all the other mini-maps videos I made is you'll notice if I add in a cube to the scene, and then maybe we scale it up by 10. Oops. We'll do in all axis, so it's a little bit bigger. There we go. If I center this at world origin, you'll notice world origin is right there. So typically when we made the previous mini maps, we built the level at world origin. So it was, you just pitch the camera up, you take a little picture of it, and then a lot of the logic was a lot easier to do because everything was centered at world origin. So if you happen to be dealing with a map that isn't, in that configuration, I'll show you how to calculate the offset. So in this particular example, I do have a camera actor. You can see it's already pitched up. I have the aspect ratio set to 1, so it's a perfect square. And I have the projection mode set to orthographic. And then I just chose a width where it was able to fit the whole map, and then a little bit of the blue on the outside. And that's important because we have to take a picture of our map so we can use it as an actual image for our mini map. I will say when you're taking the image, you'll want to come into your viewport settings. You'll probably want to disable the grid. Actually, let's do this. You want to switch from perspective, and you want to switch to that camera actor so you can kind of see it. And then you'll want to go in and probably disable the grid. You also you can see some sprites right there. So under the sprites option, you can actually hide all. And then if you just press escape, it'll deselect everything. That way you get a nice clean, picture of your image, or you're ready to. So you just go to the camera actor and you do a high resolution screenshot. There is one other thing I'll warn you of is I'm going to go ahead and turn on grid and my sprites. If I select the camera, so now we get an image of what the camera sees. If I go to my top orthographic perspective, and this is not using the camera, this is using like the Unreal Engine's viewport, to make your life easier, you'll want to rotate your camera to match the image that Unreal is giving you. So you'll notice mine is not quite right. You see it's this little rectangle here is in the top right corner. So I need to rotate my camera in the Z-axis by like 180 degrees, and then you can see the image is correct. If you don't do this, you're going to have to do some additional math that I'm not going to cover. So if yours is not lining up correctly, it is probably because you have your camera rotated when you're taking the snapshot in a different configuration than mine, which is why maybe some of the math isn't lining up. So just be aware of that. But once you have that set, you can just switch over to your camera. You can disable all those options for grid and whatnot to get a clean image, and then just snap a high resolution screenshot. And then once you've done that, you can click this little button here. It'll return you back into the last camera you were in. I'm going to go back to perspective. And then you'll want to import that image file. So in this one I did kind of two examples. I did one where it was inverted and then one wasn't inverted. So we'll be using the easier one just to make our lives, make this project a little simple basically. But you want to open the image and make sure that you have under texture, the advanced tab, you'll want to set it to clamp. That way it's not repeating when you're moving around the map. But now that we have that done, we're using this material file. I'm not going to go over it in this video because I've done that in the previous videos. But it's pretty simple. It just has a function to handle zoom, one for rotation, and another function for translation, which is moving the map around. The way we dynamically adjust those values is we use something called a material parameter collection, which is where you see here in the yaw, the V offset, U offset, as well as the scale. You can create a material parameter collection. You can add as many scalars as you want. set their default values, and then you can adjust them through other blueprints. And that's kind of how we modify the material on the fly. And then of course we just create a simple widget, we add the image, and we use that material, the m_map, for the image, and we set whatever size we want. So it's very, very simple. But this, normally when we've done this in the past, we've had center origin, so I'm gonna show you how to create it where you don't have that, where it's basically kind of like offset. So starting off, we're gonna create a function. I think we'll do it as maybe move MiniMap, I think will be appropriate. We'll do two functions, one to rotate the minimap and then another one to move it. And I'll show you two ways to configure your minimaps. I'll do one with a zoom and one without a zoom. So I think starting off, we'll need to get our player's position, and we are in the player blueprint here. I'm using the first person template just as a reference. So I can pull off that capsule component, and then I can say get world location. And then we will split this structure pin here, so we have the X and Y values. And then I can pull into a simple divide. And then we basically need to divide the map size based on the player's position. And that might be a little confusing. If I go to the top view, you would think that you need the size of your, I guess your level, but what you actually need is the size of your window. Now this window that you're looking at is the Unreal Engine's top-down viewport. You want the camera that you took the photo from. So in my case, it'd be this one. You see it's a lot shorter. So I need the horizontal and the vertical distance from left to right here. Now I've already kind of prefigured this out. I basically placed a cube on the far left side, and then I took that value and then I moved it to the far right side. And then I took that value and I, basically figured out the distance between those. If you expand out the level, another way you can do it is just hold the middle mouse and you can kind of drag out, and you'll get like a distance reading here. But because I have a lot of blank spots in this level, I can't really do that effectively from this camera anyways. So I recommend placing a cube, just moving over, getting your values that way. For my example, it was 9400, and you would normally need the X and the Y, but because I set the aspect ratio for the camera to 1, it's uniform on the X and Y, so I can use a single value because they're the same. But yeah, so all that is to say is we will create a variable called map size. We'll set it to be a float, compile, and then my value is 9400. So if I drag this out, we're basically dividing the player's current X position by the current map size. And then we need to basically get the offset. So we're going to create two additional variables, one for an X offset and one for a Y offset. The offset value is actually pretty easy. You just go to your level, and if I go back to perspective, you just select where your camera is. So if I click my camera, this is your offset. So negative 3200 is my offset in my X, and negative 4100 is my offset in the Y. So you can see my world origins over there. So we're just basically calculating the distance between world origin and where we placed our camera. So we'll go back over here, and for the X offset, we'll hit compile. That shows up. So I'll put in negative 3200, and then for the Y offset, it was negative 4100. So we'll compile. All right, and then we basically hold control. We'll drag the X out first. So for the X, I can then, we got to do the same thing. We got to divide the offset by the map size. And then we basically subtract that from the player's current position divided by the map size. and then we pass that into our scaler, our material parameter collection scaler for the U offset. And the way we do that is through a function called set scalar parameter value. You just choose your collection. I created one called mpc_map, which you can see right there. You target the parameter, which in this first one, since we're doing the X value, that's going to be our U offset. And then we just pass this in just like so. And it's basically the same thing for the Y. There's a few differences. So if we press Control D to duplicate that node, we can hook that in down here. We're not doing the U offset, we're doing the V offset. And then basically we're going to take the Y. So the player's current Y position, we will divide that against the current map size. And then we can get our Y offset, divide that by our map size. This would normally be the map size Y. So if you not have a uniform aspect ratio, just be aware this is map size Y, and this would be map size X. And then we can basically pull into, I think I'll move this up here, and then pull off into a subtract, pass this in down over here, and then forward that over there. So we compile and save. That's not going to do anything because we've now defined the function to move the minimap around, but we're not calling it from anywhere, so it's never going to get run. This particular template uses the first person character, and it does all of its movement in a function they defined as move. So that makes it pretty easy. So we just open up their move function, which you can see over here or at the top, and then just right at the end, just call the move minimap. And that should get us working. The other thing we'll want to do is on the event begin play, we're creating the widget and adding it to the viewport. We'll also want to move the minimap because you'll notice it spawns center, and the player is obviously not center. I mean, it might be, but in this case, my player is not, so we might as well just move the minimap to the player's current position. So we'll hit compile, save, hit play, and you'll notice the player's little pin moves out, and we're moving along, and that's working great. The only problem is if I zoom in or out, you'll notice it doesn't line up right. So I'm currently over by the wall. If I zoom out, you'll see now I'm by the wall. But if I zoom in, I'm not. So our zoom function isn't working, and we're also not rotating. But everything else is pretty much good. So I will show you how to modify this to add in the zoom function, which I showed in a previous video. So I'll do that real quick here. And then I'll also finish off showing you how to add rotation to your minimap using this offset trick. So we'll go back into our first person character. Inside the move minimap, the code is not too bad. It's a little convoluted, but it's not too much extra. Basically what we need to do is we already have a zoom variable that we're capturing in the event. So when we push the zoom button, it increases and decreases the zoom based on some clamp, and then it passes that to our scalar value. So that's already pre-set up, so we're good there. So we basically just need a way to add that in here. So let's grab our map size, and then we can multiply that by our zoom. And then this down here isn't going to work either. We're going to have to change that. So let's get rid of this here. So now our offset is being divided by the map size multiplied against the zoom factor, which is good. And that's going to be kind of the same thing over here. So I can actually just copy this, Control D to duplicate, delete this one here, pass this in over there. Current position divided by map size times our zoom, and that completes the X portion. So basically gonna do that for the Y as well. So Control D, duplicate that. And then same thing over here, we'll take the Y offset, move it up over here. We'll delete this map size, duplicate that. So basically everywhere where there was map size, you just need to multiply that by your scalar that you're using for the zoom before you divide it against either the offset or the player's position. And that should, just on its own, correct our zoom issue. So now if I zoom in, no matter where I am, it'll basically self-correct. That looks good. So as I'm zooming in, it's lining up. So now you got a mini-map that moves around, you're able to zoom in and out on a world built with an offset, so it looks great. So last but not least, to finish off, I think we will add in our simple rotation here. We'll add a different function, I think, for that. So we'll hit the little plus sign. We'll call rotate minimap. This one's actually pretty easy. You just come into a set scalar parameter value. We can get control rotation, split it, and then we can add. The reason we want to come into an add is you may need to add an offset depending on your level setup. So we'll just promote this to a variable, and I'll call this our rotation offset. We're going to set it to 0 because I don't know if I need it, but just in case your rotation isn't lining up, it'll give you a way to change it. And then we need to divide it by 360 because there's 360 degrees in a circle. The reason we have to do that, I explained in a previous video, but basically the material that we pass this value in is called custom rotator, and this rotation angle only accepts a value between 0 and 1. Obviously your player rotation is going to be a value between 0 and 360. So we need a way to reduce that to between 0 and 1. And this is how we do that. So I'm going to select the NPC map, and then we'll select yaw for our rotation. And then that is actually good. So now we just need a way to call this. And in the event graph, I think all the look code, yeah, so you got the look code, thumbstick, mouse move, that all happens in the aim function. So you can open up the aim function here. I already have it open at the top. And just at the end, we can call our custom rotate minimap function. So it's also rotating the minimap. And if I compile save, I now have a minimap that is able to rotate, zoom, and move in. That looks great. Now you'll notice it looks like it's kind of inverted. So if I'm going this way, yeah, it doesn't quite look right, but that's okay because we have an offset. So we can go into our player, hit our rotation offset. Let's try 180 degrees. Compile, save. That feels right. So now I'm going, in my mind, it's going up, and I'm looking up on the mini-map. So it would still work the other way. It just looked a little funny. So I guess it just depends on your taste or what you're looking for, but this looks good. All right, good people, I think we'll cut it here, but I hope you found some informative value that you can take into your own projects. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.